Welcome to this presentation of vector. I'm going to start with a very simple questions. This diagram shows two vectors OP and OQ. So when you see this kind of diagram, you are dealing with coordinates. You actually can convert the coordinate in the form of vector ij. So let's say you have coordinate P, which is 5, 3. So you can put the vector OP, the coordinate P always relative to O, that is OP, equal to 5i plus 3j, or sometimes you can put into the column vector, which is 5, 3. So if you understand this, part A is very simple. You just put OP as 5, 3. Now you can see here, you also have coordinate Q, which is negative 8, 4, right? So this is actually OQ. This equal to negative 8i plus 4j. Now look at part B. You have to find QO in the form of xi plus yj. So QO is negative of OQ, which is negative of OQ is negative 8i plus 4j. So your answer for QO is positive 8i minus 4j. So listen carefully here. For all the question on vector, the direction is very important. So QO is this direction. QO is 8i minus 4j, where OQ will be in this direction. This is your OQ, which is negative 8i plus 4j. So let's look at this question. You have P equal to 2a plus 3b, Q equal to 4a minus b, and R equal to HA plus H minus KB. Here they're telling you that H and K are constants. So you should know that P, Q, R, A, and B are all vector. You can use this symbol P to represent a vector. So you have P equal to 2a is a vector plus 3b, and Q equal to 4a minus b, and R equal to H, which is a constant. A is a vector plus H minus KB. So now you are given this relationship, that is R equal to 3p minus 2q, and you're required to use this information above to find the value of the constant H and K. So how to do this? If you look at it carefully, you're given R, which is HA plus H minus KB. You're given vector P as well and vector Q. So the next step when you do is substitute all this into this equation. You have R, which is HA plus H minus KB. So you have two vector A and B now, equal to 3. Your P is 2A plus 3B minus 2. Your Q is 4A minus B. Now I've reduced this to the equation which consists of two vectors, A and B only. Now I expand it. I have 6a plus 9b minus 8a plus 2b. Now I group the vector A together. 6 minus 8, I have minus 2a plus 11b. So now you have to find the value using the comparison method. Yeah, this equation now where you group your A and B together. Therefore, H should be equal to negative 2. And H minus K, which is the constant in front of vector B, equal to 11. So your H minus K equal to 11. Your H is minus 2. Your negative 2 minus K equal to 11. Therefore, negative 2 minus 11 equal to K. Your answer for K equal to negative 13. So for this question, it's very simple. You are given three vectors P, Q, and R in terms of vector A and B. And you're given one relationship, vector R equal to 3P minus 2Q. What you need to do is just substitute to get a vector equation in terms of A, then you can compare, then h equal to -2, and vector B here, you can say that h minus k equal to 11. Diagram below show a parallelogram ABCD with BED as a straight line. Given that AB, vector AB equal to 6p. So this is AB, which is equal to 6p, and AD here equal to 4q. Where is AD? AD is here, equal to 4q. And also the ratio and DE equal to 2EB. So we can put it like that, DE divided by EB equal to 2 to 1. So we know the ratio for DE should be 2. This is DE. For EB is 1. So expressed in terms of P and Q, for part A, you have to find BD. So where's BD now? Very simple, BD is here. This vector is here. Listen carefully, for vector, the direction is very important. So if you want to find vector BD, you will start with B first. So you have BA plus AD. So this start with B and end with D, that is BD. So what is BA? I know that my AB is 6p. So BA is the negative vector AB. So this equal to negative 6p. AD equal to 4q. So this is the answer for part A. So for part B, I need to find EC. Where is your EC? Your EC will be somewhere around here. This is your EC. So to find EC, I can use EB plus BC. Okay, carefully here. EC, you start with E first and end with C. In the middle, you should have the equal number, that is B. So how to find EB? You can see here EB is here, EB is here, which is 1 out of 3 portion of DB. So this is the vector DB. EB is 1 portion out of total 3 portions, so 1 over 3 of DB. So some students might put EB equal to 1 over 3 of BD. This is wrong because the direction is different, because EB should be in this direction here and DB also in this direction. But BD is at the opposite direction. So make sure you don't do that. This is wrong. The direction is very important in vector questions. So now what is your DB? Very simple. I know my BD. So DB is negative of this vector. What is your DB here? Very simple. You just multiply with negative. Negative 6p become positive 6p. Positive 4q become negative 4q. So you have 6p minus 4q. So this equal to 2p minus 4 over 3q. Now I have my EB, that is 2p minus 4 over 3q. Where's my BC? Very simple. Because this is a parallelogram. So BC equal to AD. They have the same magnitude and directions. And AB should be equal to DC also. So but now we are more interested on BC. What is your BC? Your BC should be 4Q. So simplify further. Your final answer for EC should be 2P plus 8 over 3Q. Just to remind you, for vector question, you need to practice the question yourself. So when you finish the question, you have to try it yourself. If you can't get the correct answer, you have to look at the video again. Given that O 0, 0, A negative 3, 4, and B 2, 16, find in terms of unit vector I and j. Okay, you can put this vector into I and j. There's two forms. Either you put OA equal to negative 3i plus 4j when you have coordinate A is negative 3, 4. This is equal to OA. Or you can just put it in the column form that is negative 3, 4. So for part A, you need to find AB. And what you have here, you have coordinate A, therefore you know your OA, which is equal to negative 3i plus 4j. You have coordinate B, therefore your OB equal to 2i plus 16j. So this is what you have. To find AB, you can use AO plus OB. Always remember you have to start with A and end with a B to get your AB. So what is your AO? AO is negative of OA. So you multiply with negative here. Negative 3i will become positive 3i. Positive 4j become negative 4j. Plus your OB, which is 2i plus 16j. So this equal to 3i plus 2i, you have 5i minus 4j plus 16j, you have positive 12j. So this is the vector AB in terms of the unit vector I and j. Now for part B, we have to find the unit vector in the direction of AB. How to find the unit vector in the direction of AB? You have to know the formulas. If you have a vector which is in terms of ij, xi plus yj, you can find the unit vector in the direction of A, that is this vector here, A. This equal to, this is the symbol, this equal to the vector A divided by the modulus of A. Modulus of A is this. This equal to square root of, you get the x square plus the y square. So this equal to the unit vector in the direction of A. So now you have to find the unit vector in the direction of AB. So this is your symbol. Now you put the vector which is AB, that is 5i plus 12j divided by modulus AB. So what is modulus AB? Square root of 5 square plus 12 square, which you get 13. So this you have to divide it by 13. So the answer for the unit vector in the direction of AB is 5 over 13i plus 12 over 13j. So in summary, to find a unit vector in the direction of this vector, you just put your vector that is AB divided by modulus AB. How to find the modulus AB? This is square root of 5 square plus 12 square. Make sure you understand this because this is a very common question in paper 1. Given that A is negative 2, 6, B is 4, 2, and C is MP. Find the value of M and P such that AB plus 2BC equal to 10I minus 12J. So now you're dealing with unit vector. First, you can turn the coordinate in terms of I and J. Coordinate A will be vector OA. This equal to minus 2I plus 6J. Coordinate B will be the vector OB, always relative to O. This equal to 4I plus 2J. And coordinate C will be OC. This equal to MI plus PJ. So to get this equation, first we have to find your AB. What is your AB? AB should be AO plus OB. What is your AO? AO will be negative OA. Negative of this whole thing here, you will have positive 2I minus 6J plus your OB. Your OB will be 4I plus 2J. This equal to 6I minus 6 plus 2 minus 4J. Now what is your BC? your BC equal to BO plus OC. Where is your BO? Negative of OB. Positive 4i, positive 2j will become negative 4i and negative 2j plus OC, which is MI plus PJ. Group your I terms together, you have negative 4 plus MI plus P minus 2j. Now you have your AB and your BC. Now you can substitute into this equation. Where's your AB? Your AB should be 6i minus 4j plus 2 multiply the vector BC, which is negative 4 plus MI plus P minus 2j equal to 10i minus 12j. Now for the left hand side, you have to group all the ij terms together. So what you have now, you have 6i minus 4j times in, you have positive 2 multiplied with negative 4 plus mi plus 2 multiplied with p minus 2j. This equal to 10i minus 12j. Now to group all your items together, you have 6i and here you have negative 8 plus 2mi. 6 plus negative 8, you have negative 2, then you have positive 2m here. This is your item. For your j, you have a negative 4j. Here expand it, you should have 2p minus 4j. Therefore, for the j term, you have 2p here. Negative 4 minus 4 again, you should have minus 8j. This equal to 10i minus 12j. After you get this, you should be very happy because now you can actually compare. You have the I here and the j here. You can say that minus 2 plus 2m equal to 10. So this is the first equation. Minus 2 plus 2m equal to 10. 2m equal to 10 plus 2, which is 12. Therefore, your value for m is 12 divided by 2, which is 6. Now for the j term, 2p minus 8 equal to negative 12 here. So your 2p minus 8 equal to negative 12. 2p equal to negative 12 plus 8, which is negative 4. Therefore, your p is negative 4 divided by 2, which is negative 2. So you can see here, this type of question, what you need to do is, first, you must know how to turn this coordinate A into a ij vector. The coordinate A is always relative to O, that is your OA equal to minus 2i plus 6j. So secondly, you must be able to find the vector AB and BC. Then you substitute inside. Then you group all your I terms together and your j term together. Then you compare it to find the value of the constant. Diagram below show the vector OA drawn in a Cartesian plan. So you can see here, this is your coordinate A. What is your coordinate A? 12, 5. So first you have to express OA in the form of xy, which is a column vector. So part A is very simple. That is OA in terms of column vector. That is 12, 5. For part B, you have to find the unit vector in the direction of OA. So remember, if you want to find unit vector in the direction of OA, this is the symbol. This equal to OA divided by modulus OA. So now you are dealing with column vector. So what is the modulus OA? This equal to square root of, the I term should be 12, 12 squared plus the j terms will be 5, 5 squared. This equal to 13. Now what is the unit vector in the direction of OA? This equal to the vector OA, which is 12, 5 divided by the modulus OA, which is 13. You can put your answer like that, 1 over 13, 12, 5. Some students will find this form here a bit confused because in this question, you are asked to express OA in terms of xy. This is also the same as the ij form, which you have 12i plus 5j. But for this question, you have to put in terms of the column vector because that's what you ask in these questions. Now for this unit vector in the direction of OA, you have 12, 5 here. It's actually 12i plus 5j divided by the modulus, which is 13. So the unit vector will be 12 over 13i plus 5 over 13j. This is exactly the same as this answer here. Diagram below show a parallelogram OPQR drawn on a Cartesian plane. Given that OP, where is OP? This is OP, equal to 6i plus 4j, and PQ, here is PQ, equal to negative 4i plus 5j. You have to find the vector PR. So remember, for parallelogram, you have two pair of parallel lines. You have OP. This vector is equal to the vector RQ. RQ is the same as OP, which is equal to 6i plus 4j, and your PQ equal to OR. So OR equal to PQ, which is equal to negative 4i plus 5j. So how to find PR? PR is somewhere here. PR equal to PO plus OR. Always start with your P and end with R here. So what is your PO? PO is negative of OP. OP is 6i plus 4j, so PO is negative of OP, become negative 6i minus 4j plus OR. So OR, because this is a parallelogram, OR equal to PQ, which is negative 4i plus 5j. Therefore, your answer for PR equal to negative 6i minus 4i, you got negative 10i minus 4j plus 5j, you have positive j. Diagram below show two vectors, which is OA and AB. So first you have to express OA in the form of column vector xj. So the first one is very simple because you already know your coordinate for A, which is 4, 3. Therefore, your OA equal to 4, 3. So remember, this is the same as 4i plus 3j. But you have to put the answer in terms of column vector. So your answer should be 4, 3. Now for part B, we have to find vector AB in the form of xi plus yj. So we start by writing your AB first. Your AB equal to AO plus OB. So what is your AO? Your AO will be negative of your OA. So negative 4i minus 3j. Now you have to put into the ij form plus your OB. So a lot of students make mistake here. Your B coordinate is 0, negative 5. So your OB should be equal to 0i plus negative 5j. So should be negative 5j. So your B should be negative 5j. So this equal to negative 4i, negative 3 minus 5, you have negative 8j. So this is the answer for vector AB in terms of xi plus yj. The point P, Q, R are collinear. So what does it mean by collinear? It implies that point P, point Q, and R, these 3 points, are located at the same straight line. So it's given that vector PQ equal to 4a minus 2b and vector QR equal to 3a plus 1 plus kb, where k is a constant. Find the value of k. Now listen carefully, a lot of students can't do collinear questions. If you know that PQR are collinear, first you have to choose two vectors from here. You can choose either PQ, QR, PR, and so on. So since you are given PQ and QR here, I'm going to choose these two vectors, that is PQ and QR. Then you have to put the relationship PQ equal to HQR, where H is a constant. You can see here I didn't use K because K has been used here in the vector QR. So now if you know the relationship, that is that if PQ are collinear, PQ equal to HQR. Now you can find the value K and H by using the comparison method. So now you have PQ, which is 4A minus 2B. Then you have H here. What is your QR? Your QR equal to 3A plus 1 plus KB. Now expand this, you have 3HA. Always put the constant in front, plus H multiplied with 1 plus KB. So now we have to use comparison method because you already grouped the vector A and the vector B together. So what we can say is 4 equal to 3H. Therefore, your H equal to 4 over 3 and negative 2 equal to H multiplied with 1 plus K. You can see I compare the vector A, I will get 3H equal to 4. If I compare vector B, I will have H 1 plus K equal negative 2. What's the H? 4 over 3, 1 plus K equal to negative 2. 1 plus K equal to negative 2 multiplied with 3 over 4. This will give you an answer, negative 3 over 2. Therefore, K equal to negative 3 over 2 minus 1, which is negative 5 over 2. Now for part B, you have to find the ratio of PQ ratio QR. You already have this relationship, that is PQ equal to HQR, where your H equal to 4 over 3, right? This is 4 over 3 QR. So if you put your PQ, put your vector like that, divided by QR, this equal to 4 over 3. Therefore, PQ ratio QR equal to 4 ratio 3. Diagram show a rectangle OABC and the point D lie on straight line OB. This is point D here, given that OD equal to 3 dB. So from here, you should know that OD divided by dB equal to 3, 1. So the ratio for OD will be 3, for dB equal to 1. Express OD in terms of X and Y. Now you need to express OD. So first you can see here, given that OA equal to 9x, therefore your CB equal to 9x x well. So OC equal to 5y, therefore AB also equal to 5y. So how to find OD? So first your OD equal to 3 over 4 of OB, right? Because this is your OB here in this direction, your OD also in this direction, and your OD take 3 portion, and the total is actually 3 plus 1, which is 4 portion. So we have OD equal to 3 over 4 OB. Now we have to find OB. OB is very simple because OB equal to OA plus AB. So we know that OA equal to 9x, and we know that AB equal to your OC, which is 5y. Now you substitute into this, you have 3 over 4, 9x plus 5y. This equal to 3 over 4 times 9, you have 27 over 4x plus 3 over 4 times 5, that is 15 over 4y. So the following information referring to vector A and B. You can see here A and B are given in the column form. So first one, A, to find the vector 2A minus B. So this is very simple. 2, your A is 2, 8, this vector. B is negative 1, 4. So you have 2 multiplied 2, 4 minus negative 1 become plus 1. 2 multiplied with 8, you have 16 minus 4. So the vector 2A minus B equal to 5, 12. So for part B, you have to find the unit vector in the direction of 2a minus b. So again, what you need to do is to get the vector 2a minus b, which is 5, 12, divided by the modulus of this vector. The modulus of this vector, that is modulus 2a minus b, equal to square root of 5 square plus 12 square, which is equal to 13. So divided by 13, you can put the answer 1 over 13, 5, 12. Diagram below show the triangle PQR. So you have PQR, this triangle. The point T here lies on QR such that QT, TR is 3 ratio 1. Q3 is 3, TR is 1. Expressed in terms of AB. For part A, you have to find QR. So part A is very simple. You are given PQ is 6B and PR is 4A. So your QR equal to QP plus PR. So what is your QP? Your QP is negative 6B. So can you see here PQ is 6B and QP is in the opposite direction. Therefore equal to negative 6B. Then what is your PR? Your PR is 4A. So therefore QR equal to 4A minus 6B. So for part B, we have to find PT. So you can see your PT will be here. This is your PT, which is equal to PR plus RT. So you know your PR is 4A. Now you need to find RT. How to find RT? RT is in this direction. So RT equal to 1 portion out of total 4 portion of RQ. So listen carefully, you have to use RQ because your RT direction is same as RQ. So some students make mistake, they put their RT equal to 1 over 4 of QR. So can you see here, QR is this direction where your RT is this direction. So this is actually wrong. So the direction must be equal. I have RT at this direction and RQ at this direction. So what is my RQ? I know my QR. So RQ should be negative of this, which is negative 4A plus 6B. This equal to, expand it, you have negative A plus 3 over 2B. Now we can substitute here the RT equal to negative A plus 3 over 2B. You have 4A minus A, which is 3A plus 3 over 2B.